Welcome to Easy Math TV. Here's another statistics video in our series on StatCrunch, how to use StatCrunch. But we're also going to be doing some other things today too, besides just StatCrunch. So I wanted to show you some new data. We have some pulse rates here for males and females. It's just a sample, so this is just a random sample of 40 males and 40 females and their pulse rates. And the first thing that I want to do, because our lesson really has to do with measures of relative standing and how to compare values from one data set to another, or maybe just how do you compare a value to what is expected in its distribution. So measures of relative standing is our topic. And the first thing I want to do is just kind of explain a little bit how we can use a box plot to demonstrate how spread out our data is, or how one data set might compare to another. So here we have our males and females. We're going to go to the graph menu and we're going to select box plot. So the first thing to do is to select both columns using whatever keystroke you are supposed to. On a Mac, you're supposed to hit the Command key as you're clicking. On a PC, I think it's Shift click. So we want to make sure we have both columns selected. Just ignore these first three things. The where is just going to be a pop-up, and use fences, yes. Draw boxes horizontally, yes, because that's how you see them in your homework problems. We want to mark both the mean and the median. We're going to use accessible marker colors, and we're also going to use accessible colors, an accessible color scheme in our box plots. So basically, those are the options that I decided to select. Everything else we can just kind of ignore, because my purpose here is just to compare the two sets of data. Are male and female pulse rates different from each other? And do they tend to vary about the same, or do they vary differently? That's the question that we're about to answer. Okay, so you saw everything that I selected. Now I'm going to hit compute. And here we have the two box and whisker plots directly above each other. Okay, directly above each other. So I'm going to recommend that you kind of ignore the outlier that's all the way to the right here on the female box plot, because that is an outlier. So the question that we are answering has more to do with just the data itself, like overall, what would you say? So the outlier is not really representing overall data. But we do have kind of, there is a little bit of a discrepancy here. If we were to make, so hover your mouse over the box plot and you can see where the boundaries are. You can see where your median and your mean are. And definitely for the males, both the mean and the median, median is here, the mean is here. So they both are less than the mean and the median for the females. We also seem to see that more than half of the male data. So if we were to actually just draw a vertical line here at the left edge of the box of the female data, which is at 68, because that's our Q1. This is our first quartile. So Q1 is at 68. And more than half of the male values are below that. More than half of the male data is below 68, because the median is half, remember, that's the halfway point. So so that's significant. And then the range, however, so if you look at how long the two whiskers are, the two sets of whiskers, they're kind of about the same, I would say. So there's two statements we can make about these two data sets. The first thing is that overall, I would say that the male pulse rates do tend to be slightly less than the female pulse rates overall. However, both sets of data do tend to have the same variation to them, because the variation is shown by the length of the whiskers. The length of the whiskers tells you how varied or how much variation there is in your data. And it's about the same. It doesn't have to be perfectly the same. It's about the same. So that's what we would say about these two data sets, okay? And keep in mind that we are talking about just a sample here. So this does not represent our population parameters. We're about to calculate some statistics based on the female data. And I want to show you what the 5-number summary is. So if you missed any of the previous classes, you might have missed our discussion of what a 5-number summary is. So I just want to go over that real quick before we answer some questions about relative standing. So under the stat menu, you go to summary stats by column, and we're just going to do the females. And the standard choices are already made for us here, so we're just going to stick with those. We're not going to hand select anything. Those are the numbers we want. They're all there. But the only thing I'm going to do is down below here where there's a box that says store in data table, I'm going to actually select that because I want the numbers to appear in my table instead of as a pop-up. So I'm going to hit compute. All right. So all those things were, in fact, put up here in their own separate columns. So basically, let's just slide some things over here so we can see everything. The standard error is not going to be important. That doesn't come up until later. We're also not going to be using the range today, although that does kind of give you an idea of how spread out your data is. So our 5-number summary is all here, but it's just not in order. It's not in the correct order. So if I were to put the 5-number summary in order, we would start with the min, and then Q1 is next, and then the median, and then your Q3, and then your max. Sorry, max. 5-number summary are usually given in order, and that's how they would appear in order. So the minimum is 60. Q1 is our 68. The median is 74. Q3 is 80. And our maximum was 124. So that's the 5-number summary of our female pulse rates, okay? And this is just a sample, so so these numbers are just a random sample of females, and it does give you a little bit of an idea of relative standing because you can actually see like what numbers should be in the first 25%. So in the first 25% of females, we should expect numbers somewhere between 60 and 68 maybe. The middle 50% should be somewhere between 68 and 80. That's kind of like the middle 50%, middle range. And then up here between 80 and 124, that would be above the 75th percentile. So that's in the direction of extreme, if not already extreme values. So the extreme values are at your minimum and your maximum. But where's the cutoff for those things? So how do you determine just how far or how unusual a number is? So how unusual is something? How common is something relative to other numbers in that population? So I'm going to pull over another document here that I've started typing on. So I just want to report that in the population, here's what we know about women's pulse rates. So let's say that we've been collecting data for a very long time, and once you have a large enough sample of the population, you pretty much have an idea of what the population looks like. So let's suppose that among all women, the mean, which is the Greek letter mu, is 75 beats per minute. So 75 is our measure of center that we're going to use for relative standing. And the standard deviation, which is the measure we're going to use for how far you are, or how unusual something is, how far from the mean we are, that's the population standard deviation, which is the Greek letter sigma. And that number is 8.75 beats per minute. So these numbers are both being measured in beats per minute. But what's going to give us our relative standing is what we call a z-score. So capital Z is a random variable. It's the variable name for something called the standard normal distribution. And the standard normal distribution measures exactly like the units of measure is in standard deviations. So it tells you how many standard deviations away from the mean you are. Okay, in any data that is relatively or close to a normal distribution. Okay, what it does is it converts your pulse rates in beats per minute into standard deviations. That's what it does. It's like a unit of measure that converts. So z-scores actually do measure standard deviations. So if I gave you a z-score of 1.98 and I asked you how many standard deviations from the mean that is, you would just say 1.98, because a z-score actually tells you how many standard deviations away from the mean you are. Okay, so that's the definition of a z-score. Now we're going to use z-scores to answer some questions about women's pulse rates. And I want to note that z-scores can be positive or negative, because you could be above the mean or you could be below the mean. So z-scores can be positive or they can be negative. Okay, so we should just be aware of that. All right, first question. Suppose we have a woman's pulse rate. We just took someone's pulse and the pulse rate is 78. So the question is, how many standard deviations from the mean is that? How many standard deviations away from the mean is a pulse rate of 78? So the 78 is treated as a value of x. X is, remember up at the top we said that x is pulse rates in women. So the formula for z is x, you take your x value, you subtract the mean, which is mu, and then you divide by the standard deviation sigma. So x minus the mean, calculate that, and then divide by your sigma. So I've shown that to you here. We have 78 is our x, minus 75, because that's our mean. So x minus mu is 78 minus 75. When you calculate that, you get 3. And then you divide that by your 8.75. And I did that on a calculator, and I got 0.34. We usually round z-scores to 2 decimal places. That's what we usually do, past the decimal point. So you have one number to the left of the decimal point, and then you usually have 2 numbers to the right of the decimal point. So 0.34, we would write that in a statement. We would state that a pulse rate of 78 is 0.34 standard deviations, or standard deviation, above the mean of 75. So it's basically 1/3. 0.34 is about 1/3. So think of it as 1/3 of a standard deviation. Like so So that's how far away you are, which isn't really that far. You're relatively close. I mean, you might as well be very close to the mean. So that's right around what we expect a woman's pulse rate to be. Okay? No alarm there. So, follow-up question, another woman's pulse rate is 98. So we take another person's pulse rate and we get a 98. How concerned should we be there? So again, calculate the z-score, okay? Calculate how far, how many standard deviations is that exactly? So when you subtract 98 minus 75, you get, I think it's 23 on a calculator. 23 divided by 8.75 equals 2.63. So there's this thing called the range rule of thumb. When the number of standard deviations is outside of +2 or -2, then it's considered to be statistically more extreme. Okay, statistically more extreme. So 2.63 is, in fact, bigger than +2.00, right? So the +2.00 is our range rule of thumb. Okay, that's our range rule of thumb. If our z-score is bigger than that, then we can say that our pulse rate of 98 is considered statistically more extreme. And you can see the statement right here. We could say the same thing in the other direction. If we had had a number that was below -2 standard deviations, so we're about to calculate those here down below, we're going to see what those cutoffs are for what is considered to be statistically extreme. And in fact, that's the question that's asked here. So what are the pulse rates in females that are considered to be more extreme? And we're going to use the range rule of thumb for that. So starting with the mean in the middle, I just typed this into a document here, and the mean is right in the middle, and then we're going to go +1 standard deviation away, and then we're going to go +2 standard deviations away, and then we're going to come back to the mean, and we're going to go -1 and -2 down, okay? So the way you calculate those values is you have to keep adding standard deviations. And our standard deviation value is 8.75. So if you know your value of z, if you know what your z-score is, you can get your pulse rate by taking your z-score, multiplying it by the 8.75 standard deviation, and then add your mean of 75 to that, and that will give you your pulse rate for a specific z-score. Okay, we can do that in a moment, but let's figure out where our extremes are. So I'm going to pull my calculator over here and start with the mean of 75, and we're just going to add a standard deviation to that. So our standard deviation is 8.75, okay? So we're measuring pulse rates here. So a standard deviation is 8.75. So a pulse rate of 83.75, let's put that here, 83.75, that would be +1 standard deviation, okay? Because I added 8.75. And now let's add another 8.75. So we're just going to leave off where we just were, starting with the 83.75, add another 8.75 to that, and we get 92.5. 92.5. So guess what? That's the cutoff on the upper end. That's the cutoff of what's considered to be extreme. So anything like 93 Usually when you count beats per minute, we don't get decimal values. It's always a whole number. So a 93 would be statistically more extreme, or above 94, 95. Anything above 92.5 is considered to be statistically more extreme. And in the opposite direction, what would be considered to be statistically less extreme or more extreme? So start with the mean again, 75. And now instead of adding 8.75, we're going to subtract 8.75. And I get 66.25 there. So I'm going to fill that number in here. And if you recall, that was almost at the left edge of our box plot that we made before, interestingly enough. So, okay, I need to line these up. Okay, and let's do one more. Let's subtract another 8.75 minus 8.75. We just keep adding and subtracting a standard, the number that is sigma, your standard deviation. So that's 57.5. 57.5. Okay. And I want to pull this back here. Okay. There we go. So those numbers are now lined up. So now that's going to be the extreme in the other direction. So any pulse rate that's below, that's 57 and below. So it would have to be below 57.5. So if you get a pulse rate that's 57, that's considered to be statistically more extreme. 56, 55. Those are extreme on the low end of the pulse rate scale. So basically, these numbers that you see here are considered to be basically the more common. In fact, 92.5, the farther away from the mean you get, the less common they are. But statistically more extreme is, by the range rule of thumb, is going to be more than +2 standard deviations or more than -2 standard deviations from the mean. So let's just one more example here, and then we'll be done. Suppose I have a z-score of negative 1.57. Negative 1.57. What is the pulse rate for that? So now I know what the z-score is, but I don't know, I want to know what that pulse rate actually was. So let's pull that calculator back over here. We're going to take our z-score, we're going to multiply by the standard deviation, and add the mean. That's our formula here for x, okay? So we're using our formula for x. And what I need to do is put 1.57 and then change the sign. I have to hit the plus minus sign to change it to a negative sign. And I'm multiplying that by 8.75. There's that. And now add the mean, which is 75. And it looks like the pulse rate would be 61, and let's just round it to 61.3. So 61.3 pulse rate is what has that z-score of negative 1.57, okay? So that's still within the range of something that is considered to be a little more common, but that's the number we're looking for, okay? So that's a position of relative standing. These z-scores are giving us positions of relative standing of actual values that we're interested in looking at, the actual pulse rates, okay? So Like, subscribe, comment down below if you're enjoying these videos, if they're actually helping you. And I hope this helps you study in your chapter 3 and